Alright, I want to do one final example, very similar to the airplane example. It says a ship is heading north at 12 miles per hour. The current is flowing southwest at 4 miles per hour. Find the actual bearing and speed of the ship. So, in other words, the ship's trying to go north, but there's a current that's kind of moving southwest. So what effect does that have on where the ship's actually going? So maybe if we want to diagram this out just so you can visually see it. Okay, so we've got our ship. It's heading due north. Okay, so there's our ship. It's trying to head due north. And then we've got current that's flowing southwest. Now it didn't give me an exact where southwest, so we'll just assume that it's exactly halfway between south and west. So we've got this current here. So how is that current affecting the actual bearing and speed of the ship? So let's go ahead and write first the component form of each of these vectors. So the ship, we'll call it S, is equal to its magnitude, 12, times cosine of its angle, 90 degrees, sine of its angle, 90 degrees. So I have 12 times, now cosine 90 and sine 90, you can use your calculator for that, but we know that the cosine of 90 degrees is just the x-coordinate of the point at 90 degrees, which is 0. So that's 12 times 0, 1, which becomes 0, 12. Okay. Now we need to do the same thing for the current. Okay, so let's use, I'm just going to use C for current. Its magnitude is 4. I need cosine of its angle. Now its angle, if we're in the southwest, the angle is measured off the x-axis. So it's 180. It's a half circle plus 45 more. So it's 225. Sine of 225. Now those are exact known values to me, but they involve the square roots. So I just want a decimal, so I'm going to go and just type this in. 4 times cosine 225 and 4 times sine 225. So it's negative 2.83. Okay, so there's the ship's vector and there's the current's vector. Now we want to find the actual bearing and speed of the ship. In order to do that, we need to find the resultant vector of the ship and the current. So we're going to add them together. 0 plus negative 2.83 is negative 2.83. And 12 plus negative 2.83 is 9.17. Okay, so what we're going to do, if you wanted to draw that, you certainly could. That'd be like that. So here's kind of where the ship's actually going, is right there when the current's kind of pushing it in this direction. So I want the, let's do the speed first. It's the magnitude of the resultant. So I want negative 2.83 squared plus 9.17 squared. So you can see that done here. So 9.6. So that's the actual speed of the ship with the current kind of pushing against it. The current is slowing it down. Now I want the actual bearing of it, so I want the angle. So that would be tan inverse of 9.17 divided by negative 2.83. So let's see, we want tan inverse. I get negative 72.8 degrees. Okay, now of course we've seen this a few times already. That negative 72.8 is right there. So what we need is the other side of that line. So I'm going to add 180 to that. So negative 72.8 plus 180, and I get 107.2 degrees. Now, again, the tricky part of this, that 107.2 degrees is this angle. That's not the angle that I want. The angle that we actually want is the angle that measures off of north clockwise to here. So let me try and draw this in here. This is what we actually want. Okay, that would be the actual bearing of the ship. So I'm going to find, if I take 90 away from that, that tells me that this bit here is 17.2, just inside of there. So let's see, 360 minus 17.2 tells me that the rest of that all the way around is 342.8 degrees. And that's the actual bearing of the ship. So it's not going straight north. It's off of north a little bit, but that's its directional bearing, 342.8 degrees.